What's up, guys? Sorry I'm not here today, but I can still teach you. Hopefully you guys are behaving for Miss Stokely too, right?
It's so sad he won't see Mr. Ramsey today. You don't get to see Coach Ramsey.
I know, it's a tough day. But we're still going to do some good learning. So we have been solving systems of equations. We've been solving by graphing. We even figured out the cool way to do it on a calculator. So today, I know we talked about it a little bit last week, but we're going to solve using the elimination method. So, if you look up here, we've got two equations. Neither one of them is already set to y equals, so we can't really just go ahead and plug it into a calculator. But what we can do, we can try to eliminate one of the equations or one of the variables. Let me show you what I mean. So, if I'm looking at these two equations, I've got 4x minus 3y equals negative 9, and I've got x plus y equals negative 4. You might be thinking, well, how can I eliminate one of them? Well, I'm going to show you. Think about it. If we're going to add or subtract two terms so that they can be eliminated, or at least one of them, well, they need to be the same term, right? So just by looking at this, maybe the first thing that kind of catches your eyes, let's make this x a 4x. How do we do that? By multiplying. So what I mean by that, I'm going to multiply this entire equation by a positive 4. So now we've got to distribute the 4 to each term. Right? So 4 times x is 4x. 4 times y is 4y. Can't forget my equal sign. And 4 times negative 4 is negative 16. Right? So now, how can I get one of these terms to be eliminated, to go away? What I'm going to do is subtract this top equation. I'm going to subtract the bottom equation. So let me show you what I mean. So I'm going to subtract 4x minus 4x. That's 0, right? It goes away. We eliminate it. Negative 3y, so negative 3, minus a positive 4. Right? So that gives us a negative 3 minus 4 gives us negative 7y. Right? So now I've got my equal sign. And then be careful here. Negative 9 minus a negative 16. Negative 9 minus negative 16. So that technically becomes a plus 16. So that's just going to leave us with a positive 7. Well, now we're used to these equations. We're left with a simple one-step equation, right? How can I get y by itself? That's our goal. Well, if I divide by a negative 7, y is now equal to negative 1. So if you remember, what were we actually trying to find when we were solving a systems of equations? Y'all remember? We're trying to find where they intersect. So what we just found is the y-coordinate of where these two equations are going to intersect. So we know the y, now we got to find the x. How can we do that? Somebody say it. Let's plug in this y, this negative 1, into one of our y's. It doesn't matter which one we use, right? I'm going to use this bottom one here because, let's face it, that's kind of the most simple equation up there. So I'm going to rewrite it, and I'm going to substitute a negative 1 in for y. Right, so I'm going to rewrite it over here. I'm still going to write x. Instead of writing plus y, I'm just going to write my negative 1. And that's equal to negative 4. So again, I substituted, or I plugged in this negative 1 in for that y. Now I've got a pretty simple one-step equation over there. So I'm going to add 1 to both sides. Now x equals negative 3. Ding, ding, ding. We just found that the solution, or the intersection point of these two equations, is negative 3, negative 1. Right? I know that's kind of a lot to throw at you at one time. We're going to do another example. I might let Mr. Greg try this one, see what he can do.
Oh, yeah. It's on. What I'm about to do, I'm about to open a can on this. I'm going to open a can on this one. It's going to be easy. All right. So I get what you're saying about multiplying and everything. It's kind of like when I go shopping. If I buy 5 pairs of shoes and 1 shirt, and it costs $21, if I like triple what I buy, it's going to triple my cost, right? So I get how we can do it. That makes a lot of sense. I like that. And my breath stinks. That's why I'm wearing a mask. That stink, yeah. So, all right. So you're saying we got to get either X or Y to be the same. Okay. So I see 5 and a 15, a 1 and a 5. So I like these positive numbers. I'm going to make this 5 into a 15. So I'm going to scale this whole top problem by 3. And that's going to become 15x, 3y equals 63. Alright, and I think that you said next is either add or subtract the equations, the parts that are equal, or like terms, and see if we can make one of them become 0. So if I subtract 15 minus 15 is 0, so that's what I'm going to do. That makes my x's 0, they're gone. Negative 5 minus 3 is negative 8. 15 minus that's a negative 48. I think I'm going to get this right. I'm going to get whole numbers.
I'm going to tell you something, guys, too. The goal, after you're multiplying up here, one of your terms, either your x or y or whatever letters you're using, one of them is supposed to be canceled out. So if you didn't do something correctly, maybe you need to go back and check your multiplication.
So right now, I know part of my answer, the y value could be a 6. Okay. So now we're supposed to take this y value of 6 and plug it in. So at this stage, I could plug it into one of them and just try to find it. I'm going to pick the top one just because it looks easier. But once I get my answer, I'm going to check it anyway for both parts to make sure it's right. So 5x plus 6 should be equal to 21. Okay, and we'll solve it. Move my constant over. 5 times something is 15. Well, that something is 3. So that's my other half of my answer. So I could stop here and think I'm right, but in case I screw up, I'm going to take these numbers, the x and the y, and I'm going to plug them into this equation, the one I didn't use the second time, and I'm going to see if it works. So instead of 15x, it's going to be 15 times 3. And you don't have to do this. I like to. Minus, whoa, I put a plus. All right, screwed up. Y'all didn't catch it, did you? See, I don't make mistakes, right? I do a lot, dude.
We can hit rewind and fix it.
Yeah, you did not just watch that part. That was an hallucination. Ooh, I got antlers. So that didn't happen. This is the real part. I get it right. So y is 6. And when I work that out, I should equal 15. So that's 45 minus 30. Does that equal 15? That's right. You know we do that. We open the can. Oh, yeah. Take it away, go.
All right. Woo. So let's move forward here. There we go. All right, we got another example up here. So I'm looking at my equations right off the start. This is important. If something were to go ahead and be canceled out by simply adding or subtracting, then do that. But if I look up here and check, I got a 6x minus 10y equals negative 2, and negative 2x plus 2y equals negative 6. Nothing can cancel out if I just simply, added or subtracted the two equations together. So that means I've got to multiply something. Well, if I looked at my top equation, 6 times, it would obviously be a fraction to get 2. Same thing with 10. So I need to work with my bottom equation. So I'm going to we'll cancel out our x terms. So to do that, I know I'm going to multiply, this entire equation by a number. Well, what times 2 will give me 6? I think y'all know it would be 3. So if I multiply by a positive 3, right, that's going to give me negative 2x. It's going to give me a positive 6y. And then 3 times negative 6 is going to give me a negative 18. So you might be thinking, wait, that's a positive 6x and a negative 6x. That's okay. yes, technically we could have multiplied by a negative 3 and then subtracted. But if we multiply by a positive 3, then all you got to think is, well, let's add the equations. Because if we add a 6x plus a negative 6x, they're still going to cancel, right? So 6x plus negative 6x gives us 0. And then we'll go blue, let's see, negative 10, and then plus a positive 6, right? So a negative 10, a positive 6 will give us negative 4y. That's equal to, and then be careful here, negative 10 plus a negative 18, or negative 2 minus 18, right? Will give you a negative 20. Just be careful not to mix up here. Remember, you're combining that negative 2 with the negative 18. Don't let this number kind of trip you up. So, we're left with a one-step equation. So to get y by itself, we've got to divide by a negative 4. Remember, a negative times a negative is a positive, in this case, positive 5. So, again, we know one part of our solution, right? We know our y value is a 5. So we got to find our x value. How do we find the x value? What have we been doing? Well, we're going to plug in that y into one of our equations for y. Right? Let's see. I'll use the bottom equation. Again, both equations will work. So if I plug in 5 for this y, right? I'm going to rewrite it over here. Negative 2x plus 2, instead of writing y, I'm writing 5, so 2 times 5, and that's equal to negative 6, right? So now, I'm going to bring down my negative 2x, plus 2 times 5, so plus 10, equals negative 6. We got a two-step equation over there, so I've got to subtract 10. So negative 6 minus 10 is a negative 16. To get x by itself, I'm dividing by negative 2. So x equals a positive 8. So again, our solution, or our answer, where these two equations intersect, is at 8, 5. Now be careful whenever you're writing your solution, make sure your x, the 8 is going first. So your y goes second. It's always xy, right? And remember, you guys can click pause at any time and try to solve these on your own, right? And then kind of check yourself.
Whoa, dude! I got the world in my hands.
Whoa!
You look like right here. When I reach up and wave, I can see me. It's pretty cool, dude. I'm waving at me. That's pretty cool. Woo! I control the world. So what I'm going to do is this same one again, but I'm going to do it differently and see if we get that 8-5. So,
let's see.
Yeah, let's make a note. Because we've been doing x every time. This time I'm going to try and get rid of the y values and see if we get the same solution.
Remember 8-5.
8-5. 8-5. There we go. We got it. So, I see 10 and 2. I can times this bottom one by 5 to get it to 10. So I'm going to do that this time. See if we can get the same thing. So this becomes negative 10x, positive 10y, and then a negative 30. So, I'm going to mark that out so I can see it better. Negative and a positive. So if I add these together, they make 0. So I'm going to add the two equations. So 6 plus negative 10 is negative 4x. Negative 10 plus 10 is 0. And negative 32. So divide by negative 4. X is
We're on the right track.
positive 8. Hey, that's what we got earlier. So now we're going to take 8, plug it in. So 6 times 8 minus 10y is negative 2. Change the color. 48 minus 10y is negative 2. So subtract the constant. Subtract the constant. So negative 10y is equal to negative 50.
Ooh.
I think we're getting the same answer. Y is 5.
Nice.
Yeah, we got the same answer. Woo!
Good
And
job.
me. You can see me waving at me. All right. So our last example.
Ooh.
This is for Coach Ramsey's class, mine too. So what I just proved is we can get rid of the y's or the x's, either one. So in this case, you pick one. And if Coach Ramsey wants to finish, we'll let him do his thing.
So again, if you guys are looking at these, 2 times what is 3? Obviously, that's a decimal. 4 times what to get 5, another decimal. So sometimes we can't just multiply one of the equations and be done, right? So let's think about it. What could we multiply both equations by so that we could figure out a way to cancel out one of the terms? We'll just start with the x. So, a 2 and a 3, think about that. 2 times 3 is 6. So what I'm going to do is multiply this top row by a 3, right? So I'm going to start there. 3 times 2x is 6x. 3 times positive 4 is a positive 12y. And 3 times negative 12 is negative 36. Nothing's going to cancel just yet. So, kind of what we just said, let's multiply now this bottom equation by what? A 2. Right? So now I'm going to rewrite it. 2 times 3x is 6x. 2 times negative 5y is negative 10y. And then 2 times negative 18 is negative 36. So now, let's see if we can cancel out one of these terms. Right? So I'm going to subtract, because we got 2 positive 6x's. So I'm going to subtract 6x minus 6x. Hey, we canceled out the x's. Good. Now, 12 minus negative 10. So that technically becomes a plus 10. So 12 plus 10 is 22y. And then look here, negative 36 minus a negative 36. So if we minus a negative, that's also a plus. So really we're saying negative 36 plus 36. Well, that gives us 0. And you guys, sometimes I see this, sometimes we'll see, 22y equals 0. Well, I guess I'm done. No, right? 0 is still a number. So we're still going to divide by 22 to get y by itself. And obviously you guys know 0 divided by anything is 0. So our y value is 0. Now when you get 0, it makes finding x a little bit easier, right? So let's plug in 0 in for y. I'm going to use the top equation. So I'm going to plug in 0 in for this y, right? So that becomes 2x. Obviously, when we do 4 times 0, we're going to get 0. If you want to write 0, you can, but we're not going to. Plus 0. So we'll just go ahead and write our equal sign. And it's equal to negative 12. Again, I plugged in 0 for y. So to find x, I'll divide by 2. And x equals negative 6. So our solution, get used to that term, solution. Our solution is negative 6, 0. What happens at that point? Hey, good job. That's where they intersect.
I knew it.
Yeah.
All right. Good job, our Coach Ramsey.
Hey.
Good example. I like it.
Take it away.
All right. I got a ruler this time. That's my neutral way. There's nothing else to really do here except good job. So I want to give you a word problem.
Ooh.
Where you need to set it up like this and then solve it. So this next example, you can pause it, read it. I'm going to go ahead and do it now. So, we have 6 dog leashes, 6 dog, and 6 cat brushes, 6 cat, for $45. That's what he bought. So that's one purchase. Then, later in the summer, if everything's still the same price, he bought an additional 3 dog leashes and 2 cat brushes for $19. So right off the bat, we've now set it up just like we've been doing. It's set up perfectly for elimination. A lot of times these are set up for elimination. It makes it wonderful for us, so we don't have to really think too much or rearrange anything. So we're going to scale the bottom one by 2 or 3. because those are both 6s, either one. I like to get rid of the x or whatever's here. In this case, when you make it, use the letters because the question said how many of each, like how many of the dog ones, how many of the cat ones. If I use x and y, I might get confused and get it backwards. So that's why I like to use the letters that make sense in the situation. So double it, we're going to get 6d plus 4c equals 38. So that's been scaled. They're the same, so I'm going to subtract. And we'll get negative 2c equals negative 7. So each cat brush is 350. Ooh. Oh, we got decimal. That makes sense in this situation. Money, money, money. Money. So this solution is not really going to be thought of as a point, but more of a just number price or something. So cats are 350. So we're going to take that, plug it in, either one of them. So 6 dog brushes plus 6 cats times 350 should equal $45.
45.
18 and 3 is 21. So 6 plus $21 is 45. Subtract our 21. We have 6 dog brushes equal to 24. So the dog brushes are $4 a piece. So I didn't use this one, so I'm going to try both numbers in there, both prices, and see if they work in the other equation here, since I just used the purple. Alright, so let's try. 6 times 4 is 24. 4 times 350. 7 is 14. Does 24 plus 14 equal 38? Oh, yeah, we're good. All right.
Yeah.
You have now mastered elimination. You can use the word problem, turn it into the system, and then solve it. And now, Randy's going to teach you all new stuff. I'm kind of lost now. Sub me out. I'm tagging out.
Sub him out. Sub. If you guys remember last week, we talked about another method for our madness, another method to solve these equations, right? The substitution method. So let's think about what the word substitute means, right? It's filling something in. So what we're going to do, we'll just kind of jump right into it. We've got 2 equations. Now this one is already in standard form. This one is already in standard form. This one is in slope-intercept form. But this is telling us what our y value is equal to. It's equal to negative 8x. So we're not quite done with the y. We don't know exactly what it is. But we can substitute negative 8x. I'll change colors here. We can substitute negative 8x in for this y, because we know what y is equal to. It's equal to negative 8x. So I'm going to rewrite this equation, but instead of writing y, I'm going to write negative 8x. Let me show you. So negative 7x minus 7 times, not times y, but times negative 8x, and that is equal to a nice 0, right? What you guys are not going to make on this assignment. So, now, if you notice, we don't have 2 separate variables. We just have one variable. We have an x. It's going to make it a lot easier to deal with. So let's clean up this problem a little bit. I'm going to rewrite my negative 7x. And then I've got negative 7 times negative 8x. 8 times 7 is 56. That becomes a positive 56x. And it's equal to 0. Now, what can I do on this left side? Hopefully somebody said it or somebody noticed it. I've got like terms that I can combine. So a positive 56 and a negative 7, we can rewrite that as 49x, and it's equal to 0. Don't freak out because you got a big number, right? Because we're going to divide by 49 to get x by itself. So we now know that x is equal to 0. But we're not done yet, right? We're going to now substitute the 0 in for our x. Now, you can definitely use both equations, But think about it. We already have a y by itself, so let's just plug in that 0 into our negative 8x, or let's plug in our 0 in for x, right? So y is equal to, obviously, negative 8 times 0 gives you a 0 as well. So y is equal to 0. So that means our solution is 0, 0. Now let me just show you. If we plugged in a 0 for x up here and a 0 for y, well, obviously, negative 7 times 0 is 0, minus 0 equals 0. Right? So we solve this system of equations using the substitution method. Right?
Now, I know Randy's taught y'all another way, graphing.
Ooh.
So just compare how fast it took that to graphing this and thinking I got to get out a graph and draw it and scale. Oh, see how long it takes us to get. I like his method there. Substitution's probably the fastest. So I've got to rearrange that to slope-intercept form. So pick a color and actually use it. Plus 7x. So I have negative 7y equals 7x. I have to divide by negative 7. So this slope-intercept form is negative x. And then I have y equals negative 8x. So if I go to graph these, what's my y-intercept here? I'm going to start at 0 and go down 1, right 1. So down 1, right 1. Okay, you're going to probably do that for a while just because you don't know the other part of the answer yet. And then I can do the opposite backwards.
Yeah.
Little do I know the answer's already there, I just haven't got it. So there I've got my points. Now I'm going to draw the other one. So negative 8x, so I start at 0. So I'll start here.
There you go.
I'm going to go down 8, somewhere down here, and then over 1, so I'm way down there. Then I'm like way up here, 8, over 1. And then I overlooked it, there's my answer, 0, 0. I see a lot of people overlooking that, so that's why I like the other way better.
Substitution. Good.
So we got the same answer, 2 different methods.
Awesome.
Yeah, I'm scared, Coach Rams, you do that one. That's weird. Nice numbers and letters everywhere.
Okay, so again, now this time, they're not telling us, or this example is not telling us what one of the letters is equal to, but we're still going to try to solve this using the substitution method. So how are we going to do that? Well, let's get one of our letters by itself, right? What I'm going to do, this top equation up here, it's just one step, and then I'll have y by itself. What is that? What do we got to do? Well, to get this y by itself, we're going to do the opposite of multiplication. So what I'm going to do is divide by 3 to both sides. I'm going to rewrite it over here so we can see it a little better. So I'm dividing by 3 to get rid of that 3, so y is by itself. Negative 12 divided by a positive 3 is a negative 4. So now I know what my y is equal to. My y is equal to negative 4. So hopefully that's kind of telling you something. You know, in our final answer, we know it's something negative 4. So if this was a multiple choice test or ELC or ACT, kind of get that in your mind. You know your answer is going to have a negative 4 in the y value, right, in the y spot. But we're not done. Let's figure out where these 2 equations intersect. So we're going to substitute this negative 4 into the y. What I'm going to do, I'm going to put it in. We'll put it in right here. We're going to be a little tricky with it, right? So let's see. Let's go 5x is equal to 1 minus a negative 4. Right? 1 minus a negative 4. So let's clean it up a little bit. Now it's 5x equals, well, a minus negative 4, that's technically a plus 4. So we know that's actually a 1 plus a 4, which is 5. To get x by itself,
Cinco.
I'm just going to divide by 5. So my x equals 1.
No.
Now, keep in mind, we're not really done yet. We're trying to find the solution. We're going to put it in coordinate form, right? So final answer here, it's 1, -4. Right? This is where these two lines, these two equations, intercept at 1, -4.
I agree. Wahoo. All right. Yeah, I'll explain that. My bald got cold. You know, my baldness, it's cold, but not my ears and the rest of me, just my bald. So, all right, here we go. We'll try a different one.
Whoa.
I gotta get the bad ones. All right, so I'm gonna try what you said. Make it equal some letter, like y equals or x equals. All right, so I like. Well, I'm gonna try that one because it's on top. I'm gonna make this y equals. All right, so I'm gonna divide by 4. I'm gonna use a different color. I can't see that. Divide by 4. Divide each term by 4. And I'm going to get 1y is equal to 3, that's positive, plus 1/2 x. Oh man, you gave me fractions.
Oh no.
Dennis the menace here. Alright, so this is what y equals. So in my other equation, what y is, I'm going to replace it with this stuff. Alright, so let's rewrite it as -2 times, but instead of y, it's all this. So I'm going to have some distributive property to go with here in a minute. And then equal sign, 6 minus 7x.
Whoa.
So again, we took this stuff, that's what y is equal to, and just plugged it in right there. So I just took this stuff and went, replaced it. And now, first step, I'm going to distribute. That's going to give me a -6. It's going to give me a -x, or 1x, equals 6 minus 7x. Oh, this is such a long, crazy problem. Alright, so now I got variable on both sides. I've got it here and here. Oh, I'm going to add 7. I'm going to bring these x's over here. I think that'll keep it positive.
Mm-hmm.
I'm less likely to screw it up if it's positive.
Remember what I tell you guys, this is a case where you do want to keep your x's positive.
-6 plus 6x is equal to 6.
Whoa, a lot of 6.
Let's fix that. Let's add 6. Alright, gallon, it's 12. So I'm going to come over here. 6x equals 12. By 6, so x is 2.
Nice.
So all that just to get a little number 2. At least it's a whole number. So right now, we're at 2 something. Oh, wait. I hit the wrong button. It's because my ball's cold. Alright, so now what am I supposed to do? I done forgot. It's a lot of work. Take x and plug it in. Alright, so let's plug it in here. Use orange. So 2 times 2 plus 12 should equal 4y. So 4 plus 2 is 16.
Mm-hmm.
16 equals 4y. Divided by 4. We get y is 4. So right now, that's what I'm thinking. I'm going to try and check it, so I have to use them both here. Alright, so let's plug everything in there using maroon. So -2 times y, 4, should be equal to 6 minus 7 times x. So -8 equals 6 minus, that's 14. Yeah.
Oh yeah,
Totally.
we're cool.
I'm rocking it. Woo.
What else could we have done? We could have actually plugged it into another equation, right? Because we found out what x is. In this equation that we found, y is already by itself. So if we plug in a 2 for this x, 2 times 1/2, well that's 1, half of 2 is 1, plus 3 is 4. So right, gives us all 3 of those equations work. This one, probably your safest bet, shortest equation, maybe the one you want to go with, but if you're a little unsure, like Mr. Greg did, he checked it in both of these, and it worked for both equations as well, right? So if you're kind of pressed for time, maybe plug it into your shortest equation.
That
Just kind of a tip.
I agree, yeah. Thank you for pointing that out. That took forever. Ay.
All right.
You can do the last one.
We'll try to get this one done pretty quick, guys. I know the video's getting longer, but
Hip
thank
house.
you guys for keeping attention. Let's work through one more. Right. So here we actually already have what y is equal to. Now it's not a whole number, but we know that y is equal to 3x plus 2. So let's just kind of jump right into that. Let's substitute 3x plus 2 in for the y. Right, so I'm going to rewrite it, okay? So still going to write 5x plus 3, not 3 times y, but 3 times 3x plus 2, right? And it's equal to 20. Make that 0. Okay, so now I'm going to clean it up a little bit. I'm down to just having one variable, so I know that I can solve for that x. So I'm going to go ahead and distribute here. So 5x plus 3 times 3x is 9x plus 3 times 2, which is a positive 6, equals 20. Now what can I do? Hey, good job. We can combine like terms, right? A 5x and a 9x is actually a 14x, and then plus 6 equals 20. Simple two-step equation now. Right, you guys I know can solve this in your sleep. Going to subtract 6. So 14x equals 14. You guys know that 14 divided by 14 is 1. So we know that our x value is 1. We don't know our y just yet, but we know what y is equal to. Y is equal to 3x plus 2. So let's substitute this x. I'm just going to make it a 1. I'm going to draw it right there. So instead of an x, it's a 1, so 3 times 1 is 3, plus 2 is 5. Right? Now, if I plugged in my x and y over here, 5 times 1 is 5, plus 3 times 5, so 3 times 5 is 15, so 5 plus 15 equals 20. Right? So it works both ways. So we found that these two equations intersect at 1, 5 on my graph. Right?
1, 5, right there.
Perfect.
Yay.
All right, so I think that's enough example for you guys for now.
I don't know how he's standing over there. He must be on the island. Yeah, this boat's kind of, the room flooded.
So now you guys are going to get a worksheet, give you a little bit of problems to work out on your own. Hopefully you got a little bit of time left. But thank you guys for watching.
Oh, wait, there's my broom. Quidditch!